Alrighty, friends, buckle up. This is a long day of notes. Only good news is tomorrow is a short day of notes. It's kind of a continuation of what we're going to talk about today. The other good news is this is something you did in Algebra 2. It's going to look a little bit different now, but it should be relatively familiar. We are going to be talking about arithmetic and geometric sequences. And a sequence is a function that takes you from the whole numbers to the real numbers. And then what that means is right here. It says this means that we are able to plug in whole numbers. So you only plug in 0, 1, 2, 3, and then you will get out any real number. So it doesn't create a line, it creates a series of dots. You put in a 0, you get out a number. You put in a 1, you get out a number. But that doesn't assume that there's a connection in between them like we do when we do graphing of linear equations or some like quadratic equations. So that's what this is saying. As a result, when we graph the sequence, we will have points, but we cannot connect them. So we'll see all of that. So we're going to talk about two specific kinds. Here we have a sequence defined by this. And what this is telling you is that you're looking for what we call the nth term. You're looking for some number in the list. So we would have like my 0th term, which is like your starting term, then A1, A sub 2, A sub 3. And it's just telling you like where you are in that list. And then it's giving you a rule of what you do. And this n is the term number that you want. So if you want the 5th term, you're plugging in a 5. You want the 4th term, you're plugging in a 4, and so on. It says find A1 and A7. So to find A sub 1, we say A sub 1 because it's a subscript. I'm just plugging in the term number. And so A sub 1 is going to be a 1. And then if I want A sub 7, it's saying, hey, what would be that 7th term? So I'm going to go ahead and plug in a 7. And A sub 7 is going to be 25. So we're generating what terms would be in those positions of the sequence. And we're going to study, like I started off saying, two concepts, both arithmetic and geometric. So we're going to look at those. And that's going to kind of take us through here. We want to make sure that we understand the similarities and the differences. First, we're going to talk about what are called arithmetic sequences, and they have a specific pattern to them. So the successive terms, meaning one after the other, have what we call a common difference. Meaning the numbers go up or down by the same value. And in our formulas, that's going to be notated as a lowercase d. That's going to be the common difference. So if I had like 2, 5, 8, 11, as you go, these are going up by 3, and that would be my common difference. And these are always going to be adding or subtracting as you go term to term. So as you move along the line of numbers, you are either adding the same value or subtracting the same value to get to the next one. So make sure that you kind of understand that vocabulary of common difference for sure in this arithmetic. All right, let's take a look at some formulas right here. They're really the same. This one is just saying, hey, well, let's identify what these are talking about. A sub 0 is going to be like your initial value, your start value, but you don't always know that. D is, like we talked about, the common difference, the space between the values. And then A sub k is just going to be like the kth term, or if it's A sub n, it's the nth term of the sequence. So if it's A sub 7, looking for the 7th term, and so on. So there's two different ways. One is if you know the initial term, like what the starting number is. And if you use that, you're simply going to add the common difference as many times as you need to get to that next n. And kind of keep in mind that this essentially looks linear, mx plus b-ish. So you don't have squares or anything weird going on. Now, this is a little bit more of an expansive version of that. And this one is like, hey, what if I do not know the first term? So this is if I don't know the initial value in that list. So then this is going to be the term that you're trying to get to. So this is what you want to have at the end. This is the term that you do know, and so this is what you're going to start at. It's going to be the known term. Maybe you know the third term or the fifth term. This is going to be just that common difference, space between the values. Oops, I'm saying values, so I'm writing values. And then this number n has to match this number n. So that's whatever term number you are looking for. And then this k right here has to match this k right here. So what this is essentially finding, this is finding the space between the terms. Oops. So if I'm on the second term and I'm trying to get to the fifth term, I'd be doing 5 minus 3. I can't remember what I said actually. If I'm on the second term and I'm trying to get to the fifth term, I would be doing 5 minus 2 and say, oh, I'm going to be using my common difference 3 times because there's spaces, 3 spaces between the 2 terms I'm kind of trying to get to. And we'll see this in action. Arithmetic sequences behave like linear functions. That's a key thing to look at because then you know that you can visualize kind of that. We use mx plus b, and that's vaguely familiar to this a sub 0 plus dn. This would be similar to our common difference because that's that rate of change. So just kind of thinking about that, they behave linearly, but they wouldn't be continuous. So you might have dots if you mapped out what you put in and what you got out. Like you put in your n and got out your a sub n, they might map out to look like a line, but you do not connect them because you're only plugging in whole numbers, so you don't have any values in between. And you're gonna, like it says here, increasing arithmetic sequences increase equally each step. And all that's saying is that the slope would stay the same, you just don't connect them. So for example, let's take a look at the one that they gave us here. And let's make a table of values for ourselves where we're going to just get like the first, I don't know how many terms. And I never plug in negative numbers like we would on graphing a function. You only start with whole numbers. That's what we said right up at the very top. You're going to only start with whole numbers. The whole numbers are the counting numbers plus 0. So 0, 1, 2, 3. That'll give us a good idea. And then you're just literally going, hey, to find the 0th term or my initial term, I'm going to plug in 0 and I'm going to get out 1. To get the term 1, I'm going to plug in a 1 and get out a 4. And so on. When I plug in a 2, I'm going to get out a 7. And when I plug in a 3, I'm going to get out a 10. So if I plot those points, 0, 1, 1, 4, 2, 7, and then 3, 10 is already like off this chart. They are going up 3 over 1. I do not connect them because they are separate individual pieces and I can't plug anything in between the whole numbers, so there are no spaces in between them. So these are what we call discrete, meaning they are separate and you do not connect them. So it says for each of the following, and these are the kind of things that you're going to be doing. Like these are the examples of what you will be doing when you go to do your actual homework. Okay. So for each of the following, determine if it could be arithmetic, meaning does it have a common difference? Keeping in mind, and I'm going to actually go back up here and put this up here, to find that common difference, you can take any term minus the term before it. So if you want to write that in fancy language, you could take any term and then subtract the term that would have been 1 before it. So like in this, let's start over here actually, since I just brought that up. To find the common difference, I can just take the difference between any term and the one before it. So like here, to find it, I would take 13 minus 8, and that means that's a plus 4. 8 minus 3 means that's, 5 plus 5. And then from here to here, I'd be taking 3 minus negative 2, which is a plus 5. And negative 2 minus negative 7 would give me a plus 5 also. And you might just be able to look at it and be like, oh yeah, these are going up by 5s. And so this one is indeed arithmetic. because that common difference is a 5. And the numbers might be going down in value. Here, if I'm looking to go from 1 to -2, that's down 3. From -2 up to +3 is +5. Then from 3 down to -4 is -7. And then, so you can see that there's a pattern that you would be able to describe, but there's no common difference. It's not going up or down by the same number all the time. And because of that, we know that this one is not arithmetic. There's other patterns that you can see, but it's not an arithmetic pattern. Okay, what if you have the formula? Well, looking at it, it doesn't seem like it's going to be arithmetic because it's not linear. So I'm just kind of thinking over here that I expect this to be a no, since it's not linear and these behave in a linear fashion. But what I would do is I would plug in a few numbers. 0 squared minus 3 will give me -3. My next term would be 1 squared minus 3, so I would get -2, and so on. So I just get enough to kind of establish my common difference if there is one. And now that I have a series of numbers, like I could write them out like we did in the other examples where I would have 3, -2, 1, 6, then I can be like, hey, that's going down by 5, that one's going back up by 3, that one's going up by 5. So this is going to be a no because there's no common difference and it's not linear. Similar thinking here. This one kind of does look linear. It's sort of got an mx plus b vibe going. So I'm thinking this is going to be a yes, but to triple check, I'm going to try my s sub 0 by plugging in a 0 and getting out a 6. Plug in a 1 and get out a 4. Get a couple more going. You want to have enough to establish that there's truly a pattern. And probably this will do the trick. So if I look at my values that I got, they would have kind of lined up in a sequence like this and kept going. I can see here, this went down by 2, this went down by 2, this went down by 2. So this is going to be a yes. This is arithmetic. And it is arithmetic because there's a common difference of -2. So really be able to identify by looking either at a function and generating some terms, or looking at the terms and deciding if it is common, has a common difference, and is therefore arithmetic. Okay, now we get the fun of going into some more complicated versions of this. So let's use our big brains. Let a sub n be an arithmetic sequence. It's going to be really important that you pay attention to whether they tell you it's arithmetic, geometric, or not, because you're going to have to know like what rules to apply and so on. So we know the third term in the list. We know the common difference. We're supposed to find the expression. So basically that's using the formula and then use that expression to find A12. So there's going to be kind of two phases to this. So if I go back to my original notes, my formula that I would use, since they didn't give me the initial term, is the second one in my notes that looks like this. So I am starting at a sub 3. So I'm starting at a sub 3, and I'm trying to just find my a sub n expression. Okay, I know the common difference is -3 because they told me. And then I am going to put in here that I am going to find the space between these two things, the nth term and the third term. Because you're essentially saying, hey, I'm going to start at this spot. I'm going to take away 3 this many times. Now, which things do I know? I know that a sub 3 is 8. I know that d is -3. And I'm going to use this to develop my expression. You do, however, need to simplify this. And so this is going to require you to distribute that -3. Be careful because the -3's cancel out to become positive, and also they become 9. And so when I'm done, my general expression for like how to find these terms is going to be -3n plus 17, or you could write it as 17 minus 3n. that is a thing I'm going to have to be able to do. I'm going to have to be able to start with the general formula and use the information given to create my expression or my rule. So now I can find whatever they want, because now I know that this is the rule for this particular sequence. And so when they want me to find a sub 12, all I have to do is plug that 12 into the rule that I created, and the 12th number in my list is going to turn out to be negative 19. So that's kind of a two-step process. Let's take a look here. Let a sub n be arithmetic. We know the second term is 7 and the sixth term is 9. Find the expression for a sub n. Okay, that means that we're going to be using our rule. We're going to figure out the rule and then use the expression to find this. That's going to be like step 2. We don't involve this in our initial process. So I would actually encourage you to turn off the video and then do the same process as we did here to see if this is something you're able to do on your own. And then come back and watch to see if you did it properly. Totally up to you. Okay, so what do I know? I'm going to start with this general formula that any term is going to be whatever my start term was, adding my common difference, n minus k times. That's going to be kind of my starting ground for each of these things. That's my formula. In this particular problem, I'm going to be finding my a sub n, starting at a2 because I did not know the initial term. And then I'm going to be adding my common difference, n minus k times. So let's plug in what we know. I know that the second term is 7. I know that oh, shoot, they didn't tell me common difference. So I had to figure that out first. Okay, so we're going to have to, I didn't read through that carefully because it is not actually the identical process. So we're going to have to figure out what that common difference is. And so I'm kind of still using the same thing. I'm going to be saying, hey, I'm going from my starting spot of second term to my ending spot of sixth term. I'm going to be adding my common difference, which is 9. And then the number of spaces between these two will ultimately be 4. So I'm going to be trying to figure out my common difference. Why did I decide it was 9? I have no idea. I'm majorly messing this up, so let's start over. I just don't want you to be confused, and I definitely don't want to start the video over. Okay, so here's what we've got. This is the only formula we have. And so what we're trying to first do is find out the common difference. I just made the assumption they were going to give it to me, and they're not, so I got to find it. So when you're trying to find something that can be the only unknown, you're going to have to know everything else, which we do, because we know from what they gave us that a sub 6 is 9. We know that the second term is 7, and we do not know the common difference, but we know that the space between the sixth and second term means we're going to use that common difference 4 times to get there. So now I'm just going to do some algebra. I'm going to have that 2 equals the common difference times 4. So in this case, the common difference is 1/2 because 2 over 4 reduces. Okay, now I can go to phase 2. And now I'm going to try to figure out what my rule is. So I've got to go back to the same thing, but now I'm trying to find a rule keeping the a sub n in place. All right, well, I'm going to start at what I had, which is a sub 2. I'm going to add my common difference, and I'm going to be finding the space from n to the second term. So what do I know in there? I know that a sub 2 is 7. I know my common difference is 1/2. So I have to simplify by distributing my 1/2. And we've done this process before. It's just had easier numbers. So I'm going to end up with 1/2 n plus 6. So that is the expression that they want for a sub n. And that was by far trickier because I first had to find the difference between the two terms that they gave me. Because what they're telling you is like, hey, the second term is 7, and then we don't know the third, we don't know the fourth or the fifth, but we do know the sixth term is a 9. So what are you adding to get there? And you would have done that 1, 2, 3, 4 times. The space between them was 4. So that's how we were kind of working out what we would get. And then finally, the easy part would be to say, well, the 24th term will be 1/2 of 24 plus 6, and that's going to turn out to be 18. That is about as bad as it gets, because you had to find your own common difference, then you had to use it to find the equation, and then you had to use it to find that 24th value. And the fact that you're having to do all those layers now means you should expect to have to do all those layers when you go to do your homework. All right, the last example for arithmetic. Several terms of the sequence are shown. Find an expression for a sub n and then use the expression. We're doing the same thing, but we're getting the information in a different manner. So if I look over at my graph and I start to write out what I know that a sub 0 is 8, a sub 1 is 6. When I put in my second right here, that is going to be 4. And then my third is 2. And my fourth is at 1. So my outcomes are 8, 6, 4, 2, 1. And so if I look at those oh, actually that dot's on 0. Duh. So this last guy is a 0. I'm killing it today. Okay, so when I look here, these are going to go down by 2, go down by 2, and so on. And that's consistent because that is my common difference. So I had to find the common difference in a different way than what was shown up above. So if I want to go ahead here and use that formula, I can start with my first term if I wanted to, a sub 1, and then I would be adding my common difference of negative 2 n minus 1 times, because you're always finding the space between these two subscripts. So my first term, a sub 1, was a 6 minus 2 times n minus 1. So I'm going to go ahead and distribute that. So I'd have 6 minus 2n plus 2, and my final formula or expression is going to be negative 2n plus 8. Okay. Then I'm supposed to use that to find the 17th term, and all I need to do there is plug in 17, and when I do, the 17th term is negative 26. So you only really have one tool that you're using repeatedly. It's just that they're giving you the information in different ways, and then you have to muscle your way through to find the remainder of what you need. Now, the bad news is we're going to dive right into geometric, which is the other kind. Now we are going to continue geometric tomorrow with a much shorter video, just adding on some trickier problems. So let's just get to going on this. Not sure why my little guys are so little there, so I'll rewrite that. But this is going to be a new concept, and it's going to be important that you can find this for yourself moving forward. So when we had arithmetic, successive terms had a common difference and you were adding or subtracting, these are going to have what's called a common ratio, which we're going to notate as R, because you are multiplying by a number to go term to term. So the way to find that ratio is to take any term that you see and divide it by the term before it, or the previous term. Or you can think of it as, hey, the ratio will be any term divided by the one before it. However it makes sense to you, but you've got to be able to figure out like, hey, how do I find that common ratio? Because that is a concept that you want to be able to understand. So we've got some formulas. I'm not sure why mine are so weirdly small, but to find any geometric term, let's start that over again. To find any geometric term, to find the nth term, if I know the initial term, I'm going to multiply it by that common ratio to the power of the term I'm looking for. So the term I'm looking for is this number, and the power I use is that same number. But as we learned with arithmetic, we don't know the initial term all the time. So sometimes they give us the third term or the fourth term. And this is just going to be that kth term, like whatever term it is in the list. Okay, so in general, if you're looking for a specific term value, you would take your starting term, multiply it by your ratio, and then again, n minus k up in the power to figure out how many spaces are between these two spots, like where you're starting and where you're ending. Because this is going to be the term that you're going to start with, and this is where you're trying to get to. So you subtract those subscript values to figure out how many spaces and how many times you're using that are. So these formulas are going to be, especially this one, because a lot of times they don't give you the first value, the initial value. That's going to be a biggie, just like we reused that formula last time repeatedly. Now, geometric sequences do not behave like a line. They will behave like an exponential function. And if you don't recall off the top of your head, exponential functions get bigger a lot faster, or they get smaller. So say like I started here and then I went to half and then to half and then to half and then to half. Those are exponentially growing or exponentially decaying. So in an example like this is telling us that our 0th term, like our initial value, if we plugged in 0, keep in mind anything to the 0 power is 1, so we'd get 8. So at 0, we're at 8. Then when we plug in a 1, we're taking 1/2 to the 1 power. Half of 8 is 4. Keep in mind PEMDAS is real, so you would do the exponential part first. If I plugged in a 2, I would do 1/2 squared, which would turn it into a 4th. Multiply it by 8 would get me down to a 2. So my second value is at 2. And then let's do one more. I would have my 8. I would have this cubed, which would turn into 1/8. So 8 times 1/8 would land me at 1. I do not connect the dots. I leave that. You can kind of see, though, that that is exponential in nature. So that is just generating points where I'm picking an n value and then I'm getting out the value that goes with it. So when I put in my 0, I got out an 8. When I put in a 1, I got out a 4. Put in a 2, got out a 2. Put in a 3, got out a 1. Okay, we're in the final stretch, my friends. Here it says, determine if it could be geometric, meaning is there a common ratio? You are not adding or subtracting. So here you would be like 3 divided by 1 is 3. 2 divided by 3 is 2/3. 6 divided by 3 is 3. But 4 divided by 6 is 2/3. So this is not geometric because it doesn't have a common ratio. Sometimes you're dividing by 3, sometimes you're dividing by 2/3, and so that's going to not be geometric because there's no r value. Here, if I'm finding my r, I'd be taking any term over the term before it, and that would be -1/2. I would take the 4, divide by the term in front of it, and that would be -1/2. I could take the -2 over the term before it, and that would be -1/2. And my last combo is 1 over the term before it. So all of these have a common ratio of -1/2. And so this is going to be geometric in nature. And you express it as -1/2. You don't say divided by 2, even though mathematically it's dividing by -2. You write it as a ratio of -1/2 because it's the number you are multiplying by. Okay, now here we're going to start off keeping in mind that when you say something is exponential, it means that your x or your variable is in the power. So just like the other ones mimicked mx plus b, you would want these to mimic where you have a variable in the power, like this. Not like that. 2 is not a variable, so I don't have a variable in the power. I have a 2, which makes it quadratic. So this one's probably not going to be common ratio and probably not going to be geometric. But to figure it out, I'm going to generate some terms. So PEMDAS being real, I'm going to square the 0 and multiply it by 3 and get 0. Then I'm going to try a 1. I'm going to try a 2. And lastly, I will try a 3. And keep in mind, this is the work that I would use to generate this. So I have generated a sequence of these numbers. And now I'm going to see, does this 3 over 0? First of all, I can't divide that because you can't divide by 0. 12 divided by 3 would give me a value of 4. 27 divided by 12 does not give me 4. So that thing is a hot mess. And this one is going to be not geometric. And the reason is going to be that there's no common ratio. Second one, I'm sort of expecting to get a common ratio because I see that it is in that exponential form where the x is in the power. So when I plug in a 0, 0 to the negative 1 is going to turn this into negative 1 power, which if you remember from your algebra days, flips that over. So this actually kicks out a 2. And you want to be able to like work your way through that because at the end of the day, some of these are going to be no calculator. Here I would have to the 1 minus 1 power, so it would turn into a 0 power, which would make that 1. Now these will get easier because here when I do 2 minus 1, I end up with 4 times 2 to the 1 power. And then lastly, if I do that third as sub 3, I would be plugging in a 3 for that variable. That'll turn into this guy. And that will turn into a 16. So I generated a 2, a 4, an 8, and a 16. And when I look, 4 divided by 2 is 2. 8 divided by 4 is 2. So I'm multiplying by 2 as I go. So my common ratio is 2. So this one is indeed geometric. So we know what we've got to do. We've got to be able to identify yes or no they're arithmetic, yes or no they're geometric, and then like why, and the why is always because it does or does not have a common ratio, does or does not have a common difference. Let's wrap up these last two. Let G be geometric. So when you're reading, you have to be careful because they're mixed together in the same unit. So now I'm thinking, okay, I'm using these formulas and it's telling me G1 is 12 and R is 2. I need the expression. That's the rule. That's the formula. And then secondly, as a second step, I'll go back and use my rule, formula, whatever you want to call it, to find G sub 4. So let's knock it out of the park here. We're going to use our sort of general formula to find any term. I take the term that I know times the common ratio, and then I find the space between where I'm starting and where I'm ending. So in this particular problem, I know G sub 1. That's what they gave me. And so I'm going to be multiplying by my common ratio, n minus 1 times. So this G sub 1 is a 12, and then R is 2, and then I'm going to put this to the n minus 1 power. Keep in mind that PEMDAS is real, so this exponential part would have to take place before the multiplication, so do not now or ever multiply those together and get like a 24 in this case. Can't do it because you got to do PEMDAS. You're going to have to do the exponential part before you do the multiplying part. So my general formula is just like this. So if you want me to find the fourth number in the list, I'm going to put in a 4 for my n's, and the fourth term will be 12 times 2 to the third. And again, that power, that exponential gets done first. So my fourth term would be 96. So it does a lot, but it's just starting with the formula and finding what you need. Finally, the grand finale. Several terms are shown. Find the expression, the rule, the formula, and then again, secondarily use this to figure it out. So let's write down what we know. We know that G sub 0 is 8. We know that G sub 1 is 4. We know that G sub 2 is 2. G sub 3 is 1. And now these become fractions, which are tricky. So if I just use what I have initially, it already told me that it was geometric. So I just have to figure out what am I multiplying as I go. And to find that ratio, I can take any term and divide by the term in front of it and find out that my ratio is 1/2. So I am taking the initial term, which I actually know, and I am multiplying it by 1/2, and technically minus 0 times, because you're always looking for the difference between these two. So in the end, this can generate my values. Oops, sorry, I was told that G sub 0. G sub 0, my initial value is 8, and then my power will just be n, because n minus 0 is the same as n. So I'm just using what I know to get a formula, and then they're asking me to use that formula to find out what would the 10th term be. So I plug in the 10, I end up with 8 over 1024, and then that can reduce, so the 10th term is 1 over 128, and you would leave that as a fraction in simplified form rather than a decimal. That was a lot of info. Probably should digest that for a couple of days. We are just going to do a little bit more with geometric tomorrow, but these essential areas are going to be what you want to focus your energy on, is like this box right here, helping me keep track of my formulas and kind of the concept of geometric. And then up here, this will help me, like, how do I know if it's arithmetic? By looking at it, by looking at the terms. How do I find the common difference? How do I use the formulas? Like, those two boxes are the gist of what we did today. The rest is just all the ways it can be applied. So good luck, my friends.